Okay, is it audible now? Am I audible? Okay, thank you very much. I got the responses. Thank you. So, okay, welcome to this lecture 5, session 1. So, we are going to start this lecture from where we have left in the last class, and so let's start learning some new things. Okay. Okay. So, welcome to the lecture 5, session 1, and okay. All right. So before starting this actual lecture content, I would just like to bring some basics, and that are not very difficult to understand. And but just for sake of completeness, I have brought these things for you. In this class, we would like to see that these concepts. One concept is a vector. So hope you understand this. What is a vector? And what is the amplitude, addition of two vectors, scalar multiplication, dot product, angle between two vectors, and matrix. What is the matrix? What is the transpose? How we can multiply two matrices? How we can find out the inverse, etc. So in this class, we are going to quickly see that so that you don't have any backlog in terms of the understanding. So let me just quickly go through these concepts so that it becomes easy for you to follow whatever the contents we are going to have this at the later point of time. Okay, so one by one we are going to pick these things. First, let me explain that what we mean by the vectors. Okay, so first concept is the vector. Initially, I would like to tell you that what is vector. So you know that whenever you have a data, so data have some attributes such as you want to measure for every person. You have a person. Let me just write pen person, and for the person you find out that what is his age and what is his weight. Okay, so it's a two-dimensional vector. Okay, so you say that on the x-axis you put age, on the y-axis let's assume that you put on the y-axis you put weight. Then every point that is there, for example this point represents some age, some weight. This point represents a different age and a different weight. This point represents a different this age and this much number, this much weight. So every point is different. So this point, if you say, for example, let's assume that it let's say 1 2 could be, this point could be say 4 1, this point could be 3 and 3. So similarly you can find out these vectors, these things. So these things actually when you represent using two values, they become a vector because they represent a different place into your space. So this is my complete vector space where I have all the x and all the y's, and whenever I pick a point it represents with respect to the x and y some values, and with respect to that we can say that this is a vector. So the general representation is such that you say that this vector is the 4 1 vector is this, 1 2 vector is this. You can say like this. This is origin. For origin you draw a line and you say that 3 3 vector is this. Okay. So typical representation for the vector is that if you say that you can say that this is a vector A, this is vector B, and this is vector C. Okay, so you can say that the vector A, and we put a bar on this to say vector A is a 4x plus y. Okay, so you can say this is a vector. Similarly, you can say B is another vector, and B could be 3x plus 3y. So you see that these are the vectors, and if you want to find out the amplitude of this vector, what do we mean by the amplitude? For example, if we have a vector A is a vector, na? If A we have a vector, and we want to find out the amplitude, okay? If I want to find out the amplitude of a vector, the amplitude of a vector A is given by this this bar. Okay, so instead of bar we can also put an arrow over here. It's equivalent. So if we want to find out what is the What is the amplitude? The amplitude, the formula is that for, because in the 2 dimension only 2 values we have, in multiple dimensions we have for each of the is it the norm of the vector? Correct. It is a norm of the vector. So you say that for this particular vector, the amplitude is going to be, or it has been changed. Okay, the amplitude is going to be say for this 4 square plus 1 square under root of this value. So for B, the amplitude is under root of 3 square plus 3 square, under root of 3 square plus 3 square. For C vector, it is under root of 1 square plus 2 square. So you can see that in this way you can find out what is the amplitude of two vectors. If you want to add two vectors, for example, if you want to add the vector A and B, so term by term they are actually added. It is 7x plus 4y. So in this way you can find out, and this would be say another vector, say D is equal to this. So you can find out where would be the 7x plus 4y. So you see that since it is 4, then 5, 6, 7 something, 7x plus 4y, it would be some vector here. Okay, 7x plus 4y. In this way you can find out another vector. You have seen that what is the addition. Two vectors can be added, and respective if you want to add them, the respective dimensions are actually added. Scalar multiplication, that is a very important part that we want to see, that what is the scalar multiplication, is what we mean by scalar multiplication. So actually if you have a vector, let me just remove this. So let's assume you have a vector. Let's assume that this is my xy dimension, and screen is not visible properly. Okay, what's the problem? It is being shared, I think. Is it visible to everybody? Can anybody tell that it is visible? It is normal. Okay, please try to see. Okay, so what I want to say, that let's assume you have a vector, this is a vector. Okay, let's assume that it is a vector A. If you multiply vector A, let's assume the vector A is equal to say 2x plus 5y. Okay, this is x, this is y, 2x plus 5y. If I multiply with a scalar number, say 3a bar. Okay, if I multiply this with a scalar number, the output is going to be, all the scalar quantities are actually multiplied. It becomes 6x plus 15y. Okay, and you can see that the 6x plus 15y would be a different vector. So where it would be, you go 6, it was say assume 2, so here would be the 6, so you can go somewhere here. And similarly onto the y-axis, you can go, earlier it was 5, so you can go 15. It would be somehow at a very distant place, but the important point that I want to mention here is that this would be a vector, and this vector would be aligned into the same way as the A it is. You please understand this. When I multiply a vector by some scalar, and then the new vector that I get is actually bigger than the previous one. It is 3 times bigger than the previous one, but the direction is same. Means both the vectors are going to be into the same direction. So this is important thing, that if you use a scalar multiplication, so this is going to happen. You understand what I mean by this? That initially if you have, this is a vector, and if you multiply with a scalar, so what is going to happen? New vector would be into the same direction, and it would be some scaling factor would be there. Okay, the amplitude would be scaled. This is only going to happen. Then a very important point comes, that is called the dot product of the two matrices. This is a very important point. So let's assume that we have this vector as A, and another this, let's call it B. So if you have two vectors and you want to multiply them, then I think the formula here, there is some problem into the formula. So this is the formula, that if you scalar multiplication is actually you can utilize the scalar multiplication to find out the angles between the two vectors. So how you find out the scalar multiplication? Let me just write. A vector is 2x plus 3y, and b vector, let me just write the vector representation. That would be, I think, more appropriate. If I write the vector A is equal to 3 2. Okay, you understand, by 3 2 it is 3x plus 2y, and vector B let I call 2 5 then the scalar multiplication, that is A dot B, is going to term by term multiplication. So it would be a new vector, say C, and C would be the multiplication 3 into 2 is 6, and 5 into 2 is 10. This is the new vector. Okay. So you see that what is the dot product of the two vectors. When you have a dot product of these two matrices, then if you want to find out what is the angle between these two vectors, so the question says that what is the angle? Let me just tell you that this is the angle. If these are the two things A and B, then this is the angle theta. If I want to find out what is the angle between two vectors, means let's assume that two things are given. 3 2 is given to me, and 2 5 is given. Two vectors is given to me, and I want to find out what is the angle between them. The formula is this, that I can find out the cos theta between them by using this formula. So just let me apply this formula on my example, the example that I have currently. So can I find out what is the angle between 3 2 and 2 5? Let me just quickly remove this. Let me quickly remove this part. So I want 3 2 and 2 5. I want to find out the my question is that I want to find out the angle between 3 2 and 2 5. Okay, what is the angle between these two vectors? So to find out these angles, what you have to do, you have to find out this dot product. That would be 3 multiplied by 2 plus 2 multiplied by 5, and then you would divide this number by the amplitude of the first vector, that is under root of 3 square plus 2 square, and then you would multiply this thing with the amplitude of B, that is 2 square plus 5 square under root of this value. So whatever value comes to you, and I'm not going to solve it, you can solve and find out what is the value. Then you take the cos inverse of this particular value, and this is going to angle between two vectors. So these things we are going to utilize. I think these things are very straightforward. I just brought them so that you understand that how they are. They are very simple, and they comes from the very intermediate mathematics. Okay, so you know all these things. These things are easy. Are you with me? Can anybody write S? Okay, are you with me? You can understand all these things, vectors? Yes, correct. Okay, I got the responses. Thank you very much. Next thing that I want to discuss is the matrix. Okay, these is also important part. In this class, we want to also doing some matrix related operations. Let me just tell you what the matrix is. Matrix actually is a representation of the some rows and columns. Let me just write 2 3 1 5 2 1 2. So this matrix has how many rows? It has 2 rows. So it is 2 cross 3 matrix. Okay, the 2 cross 3 matrix. So similarly, you can find out 3 cross 3 matrix 1 2 3 4 5 6 9 8 9. So these are the three. This is the 3 cross 3 matrix. Okay. So you know what is the matrix. Okay, so matrix is a very simple thing to say, nothing more to explain. That if you write these things in the values into the row and column format, then it is a matrix. And most of the time when we have a data, so every row represents a new data item. This is the first data item, this is the second data item, and every column represents an attribute. So this is the first attribute, second attribute, third attribute. Okay. So this is what it is, and in our cases we have how many number of attributes we take? We generally take n number of attributes with the m number of training examples. So m cross n we generally talk about. Okay. Then what is the transpose of a matrix? Transpose is a special operation that if you apply on a matrix, for example this, so every row you take this row and put it as a column. Okay, if a column, you take this column and put it as a row. You take this column and put it as a row. So every column you can take and transform it as a 1 by 1 as a column. So what are the values? The value is going to be 3 2 1 1 5 2. So transpose of this matrix is going to be this matrix, that is 3 2 1 1 5 2. Okay, this is a matrix, and here you can say that it was 2 3, so it becomes 3 cross 2. So that is a straightforward. That is not a big thing. So you see what is the transpose of the matrix. Okay. Then comes the multiplication. That is a very important operation, and we should know this operation. In case you have any problem, please let me know, because multiplication is going to be an important operation. I'm just going to give you one thing, that let's assume that the 2 3 4 5 1 2. Let me assume that this is the matrix I have, and this matrix is 2 cross uh, 2 cross k, let's assume. So another, and here you know what is the value of k. Can anybody tell what is the value of k? Can anybody tell what is the value of k? It is 3, correct. So here we have the value of k is equal to 3 because it is 2 cross 3 matrix. So next matrix, this matrix can only be multiplied with any other matrix that can be k cross. Okay, this k cross whatever number, k cross say 5 3. Okay, k cross 3. So what is k cross 3 matrix? There will be k rows. Okay, so let me write simply write anything 2 1 0, and and 3 means I have to write 3 values. Let me just don't put 3, let me just put 4 values. Okay, so 4 values means for every row there will be 4 values. Okay, so I can write 1 0 1 1 2 1 2 1 0. I'm just putting this so that it becomes easy. So now it is k cross 4. So you should know this thing that any matrix when we want to multiply two matrix, then the two matrix, the property that this particular value should be same. Okay, the first matrix should be if it is p cross k, then another matrix can be k cross n, where you can choose any number. So therefore 3 numbers you can choose. Now let me tell you that how the multiplication is done. Whenever you are going to multiply this thing, the k terms actually goes away, and now what matrix we get? We get p cross n matrix. We got p cross n. In our case, p is the 2, so we are going to have 2 lines. We are going to have 2 lines, and in each line there would be 4 numbers. Okay, because I am telling now p cross n. So what is p? You can see that p is 2. P is 2, and what is n? N is 4. So we are going to get 4 numbers. So this way, this is what the output I am going to get. Please note one thing, that whenever you are going to do the multiplication, this kind of multiplication, you have a first matrix is 2 cross 3, and there is the 3 cross 4. Then the output is 2 cross 4. Output is 2 cross 4. Okay. And now how to find out? Let me find out this value. Okay. Let me just find out this value. This value comes into the second line. Okay, into the second row. So you take the second row from here. So what are the items? Items are 4 5 and 2. Okay, just give 4 5 and 2. Okay, and since it is, what is the row number? Row number is second. So take the second row from here. What are the item? 1. Let me just change the pen color. It is 1 1 and 2. You term by term multiply. What we are going to get? If you term by term multiply, by this you get 4 4, you get 4, by this you get 5, by this you get 4, and then you find out what is the summation. 4 4 8 in 5 is 13, so you put 13 over here. Okay, similarly, can anybody tell me that what should be the value into this cell? Okay, if you have any problem, just let me know. Okay, I'm just putting these things so that we are on the same line. So okay, so what is the value over here? So in this you say that since it is the first row, so you take all these items 2 3 1. You are going to take 2, and you are going to 3 and 1, these values from this first line. And since it is the first row, first column, so you take the first column over here 2 1 0. You get 2. Let me just change the color. It is 2 and it is 1 and 0. These things are taken, and then term by term you do the multiplication. It becomes 4, it becomes 3, it becomes 0. Now what is the addition? It is 7. Okay, you get the 7 over here. So everybody can find this value. Are you with me? If you are with me, can you tell me, say, this value? Okay, can you tell me this value? Okay, I just want to find out. So therefore the first line multiplied by this thing, so it is 0, and 3 into 2 is 6, and 1, so it is 7. Okay, many of you are writing 7. That is perfectly correct. So in this way you can find out the multiplication of the two matrix. This is going to be come into the next sessions. Okay, this is important. Next thing is the inverse. How to find out the inverse? Inverse is again an important thing. And let me just tell you that you find out the inverse of the matrix, and most of the time generally when we talk about the inverse of the matrix is said to be only such that it is a square matrix, means the rows and columns are the same. Okay, so when you find out the inverse, actually when we are talking about the matrix, you can talk about, let's assume that I have 3 cross 3 matrix. Okay, square matrix. So you can say that only here all the items are 1 and all other items are 0. This is the special kind of matrix that we call I3. Okay, means of the 3 cross 3 side, all the items are 1 in the diagonal, and all other items are 0. Okay, diagonal elements are 1, all other items are 0. It's called the identity matrix. Okay. Okay, so if I have a matrix A, so I want to find out some matrix B such that if I multiply them, you know what the multiplication is, then the output should be identity matrix. If I can do something to find out this matrix, then the B is called the inverse of the matrix A. Okay, then B is called the inverse of this matrix. This is what the concept is, and you can read from your books. I think we have spent enough time. So to find out this, you have to find the adjoint of A and the determinant of A. To find out the determinant, you know that one. Let's assume we have a let's assume we have a 2 1 5 3 2 1 1 2 1. Then the determinant, you know what is the determinant? 2 multiplied by this this rows goes away. 2 multiplied by 2 minus 2 multiplied by 2 0 plus, now no, it's minus 3 multiplied by these things goes, so 1 multiplied by 1 is 1, minus 5 multiplied by 2 is 10, plus 1 multiplied by, plus 1 multiplied by, it is 1 multiplied by 1 is 1, minus 5 multiplied by 2, it is again 10. So this comes out to be, it is 0. Okay, so this comes out to be 0 plus it is minus 9 minus 27, it becomes 27, and now it is a plus 1 minus 9 to minus 9. So if I'm right, if I'm right, then it is going to be 18. Okay, 18. So this is how you find out what is the this determinant of this particular thing given a matrix is called a determinant, and this is how you find out the determinant. Then what is the adjoint? You find out the adjoint of the matrix A, and then you divide it by this thing. So you find out this part, only, and let me just see that what is the adjoint. So adjoint of adjoint is a transpose of a cofactor matrix. So you know what is the transpose. Every row is changed to the column, and column is changed to the row. The same thing. So therefore, you know how to find out a transpose. Let's see what is the cofactor matrix of the A. Okay, so for this item, let's assume in this matrix, if I want to find out the cofactor of for this, so what we are going to say, that you remove this line, and find out the determinant of this thing. Okay, and this determinant value you put over this place. Okay, and then it should be here, it should be, you also put one term minus 1 to the power I plus j, where I and j is the here you can say if index is 0, it is 0 0 item, 0 1 item, 0 2 item. Similarly, it is 1 1 1 0 item, 1 1 item. Similarly, so this is from here you can find out I and j, and then you multiply this the determinant of the remaining part, and you can write like this. So by this you get the adjoint. So what is the important property of the getting this inverse? We have seen that if you have the inverse, you multiply the things becomes 0. And non-singular matrix is such that if you a matrix if you have and you see that determinant is not equal to 0, it's a non-singular matrix. So this is a basic that from where we want to start today. I think these things are very simple, and they comes from the intermediate mathematics. So let me just go to the next slide. Here into the machine learning domain, what the problem is that most of the time when we gather the data may be coming with multiple distributions, because we may not be our source may not be the single source. It may be generating something that is as a result of various parameters. So therefore we can see that there could be various distribution into the system, and some data is coming from the first distribution, some data may be coming from the second distribution, and that distribution. Those various distributions could be possible, and also, and then the question comes that if a data is shown to me, how can I say that this particular part of the data is actually coming from the first distribution, this data from the second distribution? This is important because most of the time, if different lot of data you are going to get, and nobody is going to tell you that which particular part is coming from which distribution, then it's your responsibility to do the task. Okay, so So how to do this? This is the question that we are going to address into the next slides. So we are going to see a particular mathematical tool that is called the expectation maximization, and I try to fit a particular model. It's initially assume that, let's assume that these are the system parameters, because system parameters are not known to me. Then it initially assumes something, and then try to build upon that to get the right kind of parameters. So, and sometimes it is also possible that if you are having the data and the underlying the parameters are not known to you, such as hidden Markov model, and we will be discussing at later point of time also that how to discover these parameters. So in these scenarios, expectation maximization is going to help. So to give you a feeling, I have brought an example. Let's assume that you have two coins, okay, the coin number A, coin number B, okay, and they are not fair coins, they are biased coins. Means the probability of getting hit for A is not 0.5, and similarly it is not 0.5 for B also either. So let's assume 0.6 and 0.1, could be any value, okay. So from this understanding, let me just build an example. So let us we have two vectors x, and the x vector and z vector, and x says that means you take a coin and you flip some number of 10 number of time. Let's assume that you flip that coin 10 number of time, and then you count that how many time you got the head. And this particular concept is actually also be told as a random variable, okay. What is a random variable? That if you define an experiment and the output is actually going to come from that experiment. What is the experiment? That I am going to flip the coin, okay. And then what is my function? My function is going to call count that how many head you are going to get. So can you tell me that what is the value going to be for this function? No, you cannot tell, because until you do the experiment you cannot tell. And when you do the experiment, then you are for sure know that how many heads had been come. But if I ask you that what would happen into the next iteration, you cannot tell. So such a variable is called, such a function is called a random variable. Which function it is? That function is defined in such a way that if whenever I call this function, it is going to toss a coin 10 number of times, and it is going to tell me how many heads it has gone. So therefore the output of this function is going to be different whenever I am going to call the same function, okay. Okay, so let's assume that these x1, x2, xm represent the random variables, and z1, z2, zm represent that which particular coin I have selected, okay. So Zi actually can be the coin first or coin 2, and therefore this particular value you can tell. So see this example, I think you can relate this thing. The Z represent BAA. What means that initially I have taken the B and called the function, and now we got 5 number of heads. Then I put then I had taken the coin A, okay, and toss it 10 number of time, I got 8 head. Then I again got the coin A and toss it 10 number of time, I got 8 number of head. Then I took the B and I had coined it, and I got 4 number of head. Again I put the A, coin A, and I got 7 number of heads, okay. This you know. Let's assume I provide this information to you and I ask you that what is the probability, because you don't know what is the system parameters, actual system parameters, okay. Let's assume that you don't know the actual system parameter. Theta A and theta B means what is the probability of getting hit with this coin A and coin B, and I ask you that can you tell me what is the probability of the getting hit from the coin A. So as you know that you just count that how many time I have used this coin, okay. So for A you can count that how many time I have used, 1 2 3, so 3 times I have used this coin. So how many coin flips I have done? Can anybody tell? 30, okay, 30 time number of time, because whenever I am picking the coin I am flipping is 10 number of times. So how many times I have flipped? Because in this thing 30 number of times. Or how many heads I got? 8, 8, 8 and 7, okay. So total number of head 23. So 23 divided by 30 is the probability, expected probability, because I don't know, because it's just an observation, I don't know the actual value. So therefore I put the estimate for this this particular hat actually shows the estimate. But when we don't know the actual number, when we do some statistics to find out the things, we put a hat over that. So theta hat A means number of head using A and total number of coin flips by A. So you know that, you can find out this. So can anybody help me to find out for the B what is the probability of the getting head? Okay, what is the probability of getting head? So how many times? So you would see that how many times I have used the coin B, 20 number of times only, and how many heads I got? 5 plus 4, it is 9. So 9 by 20. So 9 by 20 is the probability. You understood this? Okay. Okay, so the same thing is told over here. Nothing great over there. The first, this was the first coin, and you have counted how many heads you got, tails you got. Now at the end, you find out what the probability. So can anybody tell that is the right value? Because this was the coin 924 head out plus 6. Is it the right probability that you were quoting earlier? It is 9 by okay 9 by 20. It is 0.45 and 0.8. So you see that these are the probabilities. Okay, you have also already computed the same thing. Okay. But the interesting problem comes that if I don't tell that, what if I don't tell about the Z? Okay, what you know what is Z? What is that? This. If I don't tell that what is the Z, then what would happen? Can you find out what is the probability? No, it is going to be very difficult. Understand? Now see, if I am not going to give you this Z, I am going to only tell you that these are the probability. I have got some coin, I have flipped it, and I got this much number of heads. You understand? Now you just see that this is the data. This is the data I have. That there is some experiment happening, and I am getting sometime 5 head, then 8 head, then 8 head, then 4 head, then 7 head. I am getting these kind of output. Nobody is telling me that which kind of coin was used. And now and I know that since we are modeling the system, I know that there are 2 coins, but but nobody is telling me if this particular coin is being used into particular case. Can I still find out with some high probabilities that which are the outcomes of which coin? This is what the question is. Is it an interesting problem? Is it an interesting problem? Okay, that if I give you only this data, okay, if I give you only this data, and I don't tell you that these in which flip which particular coin was used. So this is the problem with me. Okay, problem in hand with me, and I want to tell that I at the later I know that there are 2 coins. I know that there are 2 coins, but nobody is telling me which particular coin has been used where, in which particular trial. Now it's my job to find out this thing, and actually my job is to find out the probability of the getting head with the A and probability estimate of the probability of getting number of head with the B. This is my target, and to fulfill that target somehow we have to find out this also. Very interesting problem. So we can utilize the expectation maximization over here and this particular thing, and therefore Z that is not being given to us is called the latent variable. And expectation maximization actually framework says that you should go into this particular fashion. Okay, this is the algorithm. Just see that what is the algorithm, and we are going to see that how it can solve the problem. Look, why this problem is important. We most of the time knows that the things are coming from some underlying distributions, but those distributions may not be the pure. But we know that because we are modeling the thing, we say that let's assume that there are 5 distributions only, or 2 distributions only, or 3 distributions only. Then what are those distributions? If somehow we can find out that these are the distributions that are being used, and somehow we can find out these particular data points pertain to this particular distribution, then we are very good, because whenever a new point comes, we can find out that in which particular area it belongs. Based on that, we can say that it belongs to this particular distribution, and then we can very effectively give the classification or whatever thing. Okay, so the framework is this: you initially guess something, means you what is this? Theta t at the time t. Okay, initially you have time is 0, so theta at the time 0 is equal to, you guess, you have some guess that at the time 0 what is the probability of A and probability of getting hit by B. You randomly choose some value, and then determine for each of the items that which coin has the more probability of being producing, because we know the parameters. Then we can say that which, because we have 2 kind of different coins, So we can say that what is the probability that this particular output has been generated by coin A? What is the probability that this coin has been generated with the coin B? And based on that, we can associate with the coin which has the higher thing. We can say that this has been generated by this particular coin, and then we can modify this probability estimate by doing some calculations, and we are going to very quickly see this. Then we can modify this because now we know the assignment. If we using initial guess, we have assigned that this particular was done by the A, this was done by B, this was done by C, then we can find out the estimate. How? Because Z was actual Z was not known to us, but using this mathematical technique we have assigned, and after this assignment we can find out that what is the probability. Okay, and then we repeat this step one by one. So to go ahead, this one more mathematical concept is required. I think that concept is not very difficult to understand, but okay, that concept is not very difficult to understand. Just see this particular problem and try to answer this question. A very simple question, that if you have a coin with the probability of head 0, 3, what is the probability of getting 4 head in 12 trials? What is the probability? Means the probability of getting head is 0.3. You are flipping is how many times? 12 number of times. So how many? I think I have done something wrong. Hello. Anybody is speaking? I think please don't speak. Please. Okay. Let me continue. So I was telling that if you have a coin that has a probability of head is 0.3, okay, but you are going to flip that coin 12 number of time. What is the probability that you are going to get 4 heads out of this? Okay. So let me just write this problem over here because it's an interesting problem. Okay, so let me just tell you that it's a very binomial expression problem, and it tells that what is the probability of getting a 4 head. Okay, so if you want to get the 4 heads, okay, so what is the probability of getting 4 heads? 0.3 to the power 4. What is the but you are getting 4 heads, so you also need to find out the tails. How many tails you have? 8 tails. And what is the probability of tail? It is 0.7 to the it is 12 minus 4. Okay, 8 number of tails. So this is what important. But this in how many ways this can happen? Because you can get all the heads, all the 4 heads, then tail. Okay, the rest of the things are tail, and then you can do again. So you can say head is here, then all other heads are at the end, then all these things are tail. So how many different permutations are possible? So many permutations are possible. So you see there are 12 C4 permutation are possible, because you ultimately want to find out the 4 places where you can put the head, otherwise everywhere is tail. So 4C4 multiplied by this thing. Okay, so therefore the solution for this is 12C4. It is 12C4. Okay, let me just write correctly. It is 12C4 multiplied by 0.3 to the power 4 and 1 minus 0.3 to the power 12 minus 4. So this is what the formula is. So this also comes from the intermediate mathematics. This is nothing more than that. So this is what the formula is. You can find out. So let's apply this framework into our question. Okay. So in our question we have some outputs that you are head, tail, 5. In the first one you got 5 head. In the second one, but look, this is the scenario we are going to have now. 5, 8, 8. 4, 7 head. Okay, so in whatever way they are, so that is not important. So if 5, 7, okay, 5, 8, 5, 8. What is the value? Sorry, I forgot. 5, 8, 8, 4, 7. So 5 head, 4, 8 head, and 7 head. Similarly, all these numbers are there. Huh? So 5 head, 8 head, 8 head, 4 head, and 7 head. You can count that these many number of heads, but you don't know which particular thing is here. Okay, you don't know that which particular thing is. Which particular coin it was. Okay, so as I told you that you should go ahead by just assuming that some initial probability. So let's assume that and how to Okay, let me just 1 minute. Just 1 minute. Okay. So initially, let me guess. Okay, so let us guess whatever value you can take, but let's assume that I have taken this thing, that the probability of getting hit from A is 0.6 and 0.5. So this is the initial guess. So if this is the initial guess, then and you just consider this particular first thing. Okay, but you just consider the first one. Here you have 5 heads and 5 tails. Okay, and you have two coins A and coins B. Okay, so if you have a coin A, so coin A you have, so what is the probability that you are going to see this data? What is the probability that you are going to see this data? Means if you are flipping, what is the probability? So you see that it is 10C5 0.5, same thing. Okay, 0.5 to the power 5 and 1 minus 0.5 to the power 10 minus 5. Okay, similarly, if you have the coin B that has the I think I have written wrongly that this probability was 0.6, so you can correct it. Okay, 0.6 1 minus 0.6. Okay, so what is the probability for this thing? If the second thing you have, what is the probability? It is comes out to be 10C5 0.5 to the power 5 and 1 minus 0.5 to the power 5. Okay, so can you find out, can anybody find out, work for me and tell me that what these values are? Okay, you can very easily find out if you have a calculator. So let me, okay, can anybody find out what is the value? Okay, so if you work into the mathematics, you can use calculator, and if you come out with this value comes out to be let me just, I have written somewhere, it is also on the slide, it is 0.00079. Okay, and this is the 0.00097. Okay, these are the two values that we are going to get. If these are the two values, and then we can normalize them, because these are the only two probabilities we have. So we can see that we can normalize probability would be just take this first one and you divide by 0.00079 plus 0.00097, and similarly you can use this the denominator to divide the first one also, and if you divide this thing, so the first value becomes 0.0.45 and the second value becomes 0.55. Okay, so these are the two values that you get. Do you understand this thing? You understand this particular up to this point, that how to get these values? And if you know this, so we have written this, that the probability that if you initial guess is this, if the initial guess is this, then the probability that in this trial was done with the coin A is 0.45 and this trial was done with this second coin is 0.55. Correct? So since you are going to get the 5 heads, so you can distribute the heads among these two things also, and you can say that out of 5 heads, I would multiply this number with the 5, and now I am going to get 0.22. Okay, 2.2. Sorry, 2.2. So this, you got this number, this 2.2 number of head and 2.2 number of tails. So, and similarly, if you multiply 5 with the 0.55, the second probability, and number of head, number of tail, you see this number of tails and this much number of heads over here as a contributions. Okay, so we can do the same thing. So whatever calculation we have done for the second thing, and second thing is I think interesting one. And here, what is the difference? The difference is now we have number of head is 8 number of head, and how many tails we have? 2 number of tails. So therefore this formula changes, and here the probability remains same, and 8 number of head for the probability of getting 8 head and 2 tails is the 2 head is the 0.8 and tail is 8 minus 10 minus 8, it is 2. So here also it is power 8 and here it is a power 2. So you put these things over here, and if you use this formula to come up with the normalized thing, it comes out to be 0.8 and 0.2. Okay, so these values are again multiplied with the number of heads. How many heads we have? 8 head multiplied by 8. Okay, then it becomes 0.72, 0.8 tails, and similarly these values you get. So you do it for all the trials, and by this you assign the probability, that what is the probability that this particular trial came from this first coin, second coin, and by this you find out the weights, and then you find out the what is the weighted summation of the head and weighted summation of the tail, and you see that the weighted summation of head is 21 and 8.6. So you can utilize these values to find out the probability of getting head. 21 point. If this is the summation, what is the probability of getting head? It is 21.3 divided by 21.3 plus 8.6. Okay, you find out the summation. This is the same formula. And now from initially it was 0.6. Now our probability is going to be 0.71 and 0.61. So now the probability has changed. With this change probabilities means you are going to use these values over here, and you again going to do the same operation multiple number of time, and if you are do this enough number of time, then you are going to reach on this particular probability 0.80 and 0.52. So this is how the expectation maximization works, and you see that initially we have tried to initialize and then with some random guesses, and then we have all the hidden trials we are going to associate the coin with respect to their probabilities, and then we are going to find out what is the cumulative weight that they gain, and then at the end we are going to find out the summation, and we are going to get the probabilities. So this is the overall scenario. Okay, initially we assume the probability. This was the initial assumption 0.6, 0.5, and this is actually important to get the quick. If you have the understanding, it would be quickly going to converge. Otherwise, it is going to give you the value at the end, because you are going to perform multiple number of times. Things with the time would be actually going to give you a very near approximations. So this is what we wanted to bring in the today's table. So we are going to have a break, take a break of 5 minutes over here, and I would keep taking the questions, but they are not going to into the recording. And let me just stop the recording.